meeting. So welcome to day 2. I'm back. We are so excited to finish up the day with some really great, exciting panel presentations as well as sessions for you guys. And if you're not from Colorado, welcome to our bipolar weather that we have here. And we could have snow today and we could be 70 degrees tomorrow. So that's what we have here in Colorado. But before and again, I want to thank the panelists for the mission directorates at NASA with their priorities and future technology needs, and know that there are continuing sessions as well as you can follow up with each of the panelists while we're here as well. But before we talk and hear from the industry panelists, I want to thank our sponsors once again, because we can't do this without our sponsors. The Colorado SBDC Network and our TechSource program are the hosts, the Colorado Business Development Foundation, and our lunch sponsors, the City of Aurora, the official sponsors, Colorado Office of Economic Development and International Trade, the Colorado Minority Business Office, the parking for the free parking, City of Aurora, Aurora Economic Development Council, Visit Aurora, Colorado Air and Spaceport, Aurora Chamber of Commerce, and Adams County Economic Development. And just a little bit of information for you. If you do have a vehicle here and you've been here 2 days, you just need one. You just grab the receipt for the free parking for today, and that'll get you out of the garage. Our supporting sponsors are CU Boulder, Aerospace Ventures, our lanyard sponsors, REI Systems, and our contributing sponsors, the Space Foundation, Colorado Space Coalition, and Cyber CYA, Cover Your Assets. And many thanks to Vicki Lee, who's the Director of the Aerospace and Aviation for Denver Metro Economic Development Corporation. And if we could all just thank those sponsors, give them a hand for helping us put this event on. And of course, a key priority, all of our sponsors have tables, so please make sure you go visit them, have a conversation with them. And remember, we've got coffee way down the other end, so don't forget those vendors that are down there as well. So we're excited to hear more from our industry representatives this morning. And before, I would like to introduce Toby Jackson once again from AIAA, and she's going to help facilitate the next panel. Thanks, Toby.
Good morning. So before we hear from our industry presenters this morning, I do have one technology note. Kind of follows that we'll be hearing about technology. So it's about the parking. I understand that some of you may have had issues with the parking this morning, so I have a note from our team that says that the validation slips are very sensitive, they are very thin, and that some people are having issues getting them to scan. So the hotel will have someone at the garage if you need assistance, and if you can't find that person, if you just push the help button, they should be able to either talk to you or send someone to come help you so that you can get out of the garage and you don't have to pay. So I hope that helps. All right, switching gears a little bit, we are really excited to hear from our industry presenters this morning. So similar to the way that we did this yesterday, in order to have time to accommodate all of their presentations and Q&A, we're not going to introduce each one individually. So I would like to thank Timothy Hampton with Booz Allen Hamilton for being here today, Shane Dykman with Teledyne Brown, and John Reed with United Launch Alliance. And we're excited to hear from them. So Tim, if you wouldn't mind to come join us. Yes.
Good morning. How's everybody doing? Can you hear me okay? Yes, no? All right, perfect, thanks. I know we're running a little bit behind, and so I'm going to try to go quick through this. I don't want to be the impedance between you and lunch. That's never a good spot for a presenter. So we'll go through this sort of quickly. I'll be around all afternoon. Would love to talk to you guys afterwards. Wanted to say real quick before we get started, when Toby originally reached out to me, I thought, great, this will be a wonderful opportunity to come and chat. Then I woke up the next morning and I went, wait a minute. I've got to go talk to a group of folks who has collectively taken on the challenge of putting people in space in a sustained environment and talk to you about how to be innovative. And then I went back to bed and said, never mind, I don't think I can do that. So I did set 2 goals for today. I want to talk to you just a little bit about why Booz Allen should be part of the dialogue and how we've been part of the dialogue for quite a while, and I'd like to talk to you a little bit about how cyber and cybersecurity can be not only innovative and part of the solution, but we're not the problem. So quick show of hands, and I promise not to take it personal. When I talk to you guys about cybersecurity, how many folks in here either groan inwardly or think that we are part of the risk to cost, schedule, and performance? All right, one of you is honest. Perfect. I appreciate that. So that's the one person that I need to talk to afterwards to convince you that we are part of the solution. For the rest of you, that means that I'm happy to come and talk to you about how we put you on contract and how we work with you in the future. So we'll set up a line and take numbers, right? All kidding aside, I do want to talk just a little bit about who Booz Allen is. We're not a name that comes up frequently in conversations with NASA, and you might be surprised about, honestly, how embedded we are. So very briefly, who are we first before we talk about who we are within NASA? We're over a 100-year-old company. We've been doing business for quite a while. We think that we've got a really good recipe for how we can succeed, how we can innovate. So why us? From an ethos perspective, what we like to do is we like to solve problems. That's it. That's all I like to do. I want the hardest problems that you can bring, whether it's NASA bringing us a problem, whether it's an industry partner coming to us, whether it's a small business saying we have a solution. We want to be part of the solution. We want to be part of solving that problem. How do we do that? We take on the mission. My mission is not to make money. Yes, we're a for-profit company, but we take that to heart. Our mission is yours. So if the mission is how do we further advance getting folks to Mars, we're going to own that. If the mission is how do we secure the systems so that our ground segments are safe from a cyber attack, we're going to take that to heart. That's what we do. We think about business along several lines, and I want to just briefly mention those. We think about consulting, analytics, digital solutions, engineering, and cyber. When I say engineering, I mean real engineering. I'm not a real engineer, by the way, but we do mean real engineers. We've got folks that are doing systems engineering, systems development. We have production facilities. We have 3D printing facilities. We have a facility in El Segundo, California, where we can present, or excuse me, can produce microprocessors and microboards. So we are not the Booz Allen that you might have thought about running around in three-piece suits with PowerPoint presentations. One note for our small business partners, when you think about should you come and talk to Booz Allen, I want to introduce a little bit of how we're structured. When you talk to one of us that leads a portion of our business across NASA, we don't think of NASA in a subset. We think of NASA as part of what we consider the aerospace community. So when you talk to us from a business leadership perspective, if you talk to a NASA leader, you're also talking to someone who leads our business across the Air Force. So if you're looking at how can you grow your business, how can you grow the aperture, we can help connect you to a much larger market space than just NASA. We run one profit and loss statement. What that means is that I have almost 25,000 people. I am incentivized to help the entire business. I don't compete with other sections of Booz Allen. So if it's not my work that you bring to me, I'm happy to connect you to someone else and help your business grow. That's something that you're not going to find with all of the business partners. I didn't realize that this was a build-out slide. My apologies. We'll get here eventually. All right. Within NASA, a couple of fun facts. We have over 200 staff that are supporting NASA missions across a number of centers. You can read the centers that are up there on the slides. We have been on contract with NASA since 1963. We've been involved in Apollo, Hubble, ISS, Gateway, many of the large programs. We have significant ties back to the operations, the mission, the relationships, and we're ready to bring that forward. All right, let's talk about cyber. Very quickly, what I want to do is set the stage. Sometimes you don't think about Booz Allen when you think cyber. Why think about Booz Allen when you think about cyber, when you think about cybersecurity? Frost & Sullivan released a report this year. They found us to be the largest provider of cyber professional services in North America. We have over 5,000 staff that are focused on cyber and cybersecurity across a large portion of the federal government, across a large portion of the commercial sector. We service 29 of the Fortune Top 100 when it comes to cybersecurity services, including 18 of the top 25 banks, 3 of the top 10 retailers, and a large portion of the top automotive, oil, and gas industries. We bring a lot of experience back to your businesses, back to your problems, back to NASA when we start talking about cyber. Enough about that, let's talk about how we innovate. How does cyber become a part of the solution and not a part of the problem? A few examples for you that I'd like to bring up. We have a service offering called Cyber Foresight. It's an open source intelligence collection service offering that we do. We go and find threat data and we bring it back to you. We do it in a number of different ways. We have some data analytics on the back side of it that will enable us to do things that other folks can't do. An example of how we applied that in the aerospace community, in the satellite industry. We had a client who was worried about a large satellite constellation. Specifically, they were worried about the ground systems, the ground architecture, and the risks of running antiquated software, Windows XP. Anybody working with our satellite systems still have Windows XP out there? Okay, no more honest people left in the room, right? We know that these systems are not designed to be upgraded frequently. They run antiquated software. We came back to them in a short order. We said, these are the threats that not only can target your systems, these are where they have targeted satellite systems. This was the effect of compromising ground systems because of these vulnerabilities, and this is how you do it. It directly impacted their ability to fund and to fund accurately their vulnerability mitigation. It wasn't just cyber for compliance, it was cyber for operations. It was threat-informed cyber for operations. We're working with one of our offices, we're leading the way out of the LA office, and we're investing in creating a virtual satellite cyber range. What we want to do is we want to create and model not only the satellite, but the communications from the satellite down to the ground station onto the corporate network or development network on the back side of it, so that as we look at cyber threats, we're able to say, yes, this is what could happen. This is how a defense could work. This is how an attack could work, without running the risk of running those tests on an operational system. This again puts us in the opportunity to come back to you as an industry and say, hey, you know what? You should or shouldn't be worried. We want to be the cybersecurity partner that says, this is when you need to patch, this is when you need to defend, not we need to do all things all the time from a compliance perspective. We're very focused from looking forward on our industrial control systems, our operational technology. For those of you that aren't aware, there's a presidential directive and a National Defense Authorization Act that focuses attention and focuses requirements specifically on the need to secure operational technology and industrial control systems, robotics, power production, all of those types of things. What we are doing is we're purchasing that equipment. We're creating a lab where our cyber staff can go. They can practice techniques to attack, defend, prove out where we have vulnerabilities, where we don't have vulnerabilities, and how we answer those. All of those types of subsystems are systems that are going to need to be secured in the architectures, the technologies, the innovations that you are building, as well as the systems that you're looking to sustain today. We partnered with a company called Splunk, and we have created a service offering called Control Watch. It enables us to go and do some of the same type of cybersecurity functions that we do on our network to protect our email, and extend those protections, extend that monitoring down into the component level for industrial control systems and operational technology. That's where the fight is going. Very briefly, why do we care about the fight from a cyber perspective? We talked a lot yesterday about the economic growth of space, how it's a driver, the money that's sitting there. Your adversaries, your competimates, we like to call them, they're going to be looking for the data that's hosted at NASA, that's hosted in your companies, that will fuel their science and technology, their research and development. And it's much easier for someone to take the data off of your systems than go do the research themselves. Folks will be interested in the data that you have. You need to be interested in protecting it. Very briefly, I'm going to merge the last two slides into one. I want to talk about data analytics. It's something that came up. 2 points that I want to make to you as we start to talk data analytics. The first, and it's really covered on the next slide, but in the interest of time, I'm going to condense them. Data analytics is not a button that you can push. We do a lot of data analytics. We're very good at data analytics. I'll talk a little bit about that. I want you to, as a takeaway, understand that in order to get to the button that you push that says data analytics or big data, you have to start with the strategy. You have to understand what data you have on your systems. You have to understand how to categorize the system. The challenge from a NASA perspective is you will need to look at that across your entire enterprise, not center by center, not Ames is separate from Johnson, not Johnson is separate from headquarters. It needs to be one approach across the enterprise to get there. A couple of anecdotes on our experience and our innovation when it comes to big data analytics. We partnered with NVIDIA. You guys might have heard about them. They're a small company. They do, a little bit in the form of video displays, right? We partnered with them and we realized that we could use the graphics control processors, the graphics units on the video cards. We could offload data analytics onto those processors. We could provide faster CPU, or faster processing time. We could provide more horsepower than we typically had, and we were able to do it in a way that was almost invisible to the machines. So we were able to offload data analytics and keep the CPU space for what it was doing prior. Out of that partnership, a couple of interesting things happened. We were able to create the Deep Learning Institute, where we partnered with NVIDIA to train data science, to train data analytics, to introduce that capability back into the industry. Those folks got together, they created what's called the Data Science Bowl. That's been used across the world to fuel research, big data research, focused on treating cancer and focused on treating heart disease. We partnered with another agency that you guys might have heard of, a small agency called the NRO, National Reconnaissance Office. They know just a little bit about satellite technologies, right? We partnered with them. Ultimately, what we did is, from a data analytics perspective, we created something called iLaunch. iLaunch was a platform that, from a data analytics perspective, allowed the folks at NRO to look across platforms, across missions, and across launch facilities, and at the push of a button say, what happens when schedule slips here, and how does that impact not just one mission or one scheduling, but the entire portfolio? So you can do real-time, displayed enterprise scheduling for your missions. That's what data analytics can do for a community like this. I will close without questions in the interest of time. We can take questions? Okay, so I won't close without questions. But before I close and take questions, what I will end with is, as I look at the cyber problem in the space community, what keeps me up at night is I don't want the next movie that I watch to be, Houston, we have a cyber problem. Cyber and space are coming together. We want to be a part of the dialogue on how we fix that. One last anecdote, when we talk about big data, especially for those of you that are, we're a little bored and we're sitting there going, yeah, it's about time for a break, grab your phone. For small companies that are looking for how do we come to us, one of the things that we need from a data analytics perspective, we need access to data. What a lot of people don't realize is the more data that you analyze, the better your algorithms become. The best way that I can show that to you, and I'm not a data scientist by any stretch of the imagination, do a quick Google search for muffin or puppy problem. And you'll start to see the pictures that come up, and you'll see, is this a blueberry muffin or is this a puppy? The more exposure that the AI, the machine learning has to pictures, the faster it learns the ability to tell those. It's a fun little exercise. So very briefly, do we have questions today? All right, thank you very much for your time.
Good morning. I'm Shane Dykman with Teledyne Brown Engineering. I'd like to draw your attention to the bottom right of the slide. We're 65 years old. Tim, you look really good for 104. But I'm very excited to be here today. And first I want to do a shout out to the CBDF, to the SBDC, as well as to AIAA for putting on this inaugural event. It's quite a feat to pull off the first of its kind, and also a big expression of gratitude to NASA, because there is no public agency that inspires creativity and innovation like NASA does. And every time my fifth grade daughter puts on her NASA t-shirt to go to school, it just warms my heart. First day of kindergarten 5 years ago, What do you want to be when you grow up? I want to be an astronaut. Well, back in my civil service days, I had the privilege of being a science advisor with Marines, and one of those Marines was then Major General Charlie Bolden. And at the time that my daughter made that proclamation, well, and Administrator Bolden happened to be at NASA headquarters. So we sent him a note, and he sent a letter back to her and gave her some guidance on studying her math, studying her science, and focusing on that aspiration. So congratulations to NASA, because you're why we're all here. Since the first Venetians went to sea, it's like what Therese Griebel said yesterday: technology drives exploration. If you don't have the technology, if you can't make it to the environment, if you can't exist in that environment, because humans are pretty fragile. We don't do well underwater. We don't do well in outer space. And it's because of those small business innovations that actually enable space flight, that enable this trip that we will do someday beyond the moon. So Teledyne Brown, what we began as Brown Engineering 65 years ago in the aftermath of an operation at the end of World War II called Paperclip. Operation Paperclip was the recruitment effort of nearly 2,000 German scientists and engineers after World War II to bring them to America. One of those was Wernher von Braun, and we parked him at Fort Bliss for a few years. Since he had perfected the V2, we said, hey, why don't you come to America, help us with our program. In 1950, the Army moved that program to the Army Ballistic Missile Agency in Huntsville, Alabama, the Redstone Arsenal. And that was where Wernher von Braun was the first tech director. Problem was, in 1950, Huntsville, Alabama was a lot of cotton fields. There were no machine shops. There were no engineering firms. And it was the chamber, it was the Huntsville Chamber, that reached out nationwide and recruited a company from Marietta, Georgia, and a professional engineer from Indianapolis named Brown to come to Alabama and to start, in 1953, Brown Engineering. So when you go to 1957, where the count of space objects was 2, a dead battery silver ball named Sputnik, and the rocket body that lifted it, 100 days later, we launched Explorer 1. And Explorer 1 collected data. Sputnik beeped. Sputnik did not collect any data. It just sent a signal, and it broadcast. It didn't collect anything. Explorer 1 detected the Van Allen radiation belts and was a very, very prominent and significant science achievement. Well, shortly after that launch, NASA's created, and the Marshall Space Flight Center is founded. And Wernher von Braun became the inaugural director of the Marshall Space Flight Center. Brown Engineering has been there since the day that those doors opened in July of 1960. And to this day, we continue with the payload operations and the mission control for the International Space Station. So with past as precedent, you see at the top bar there, we have actually increased our reach from space to energy and environment, into maritime, as well as into missile defense, and more recently into geospatial. So a message for all of you to take away today. If you remember 2 words that I say, what if? What if? That's always the catalyst of innovation and creativity. Brown Engineering was founded for the what if. What if we could loft a satellite into a sustained and stable orbit? What if we could launch people into space and bring them back safely? What if we could launch people to the moon and set foot on the moon and plant a flag and then return them safely to Earth? So think of what if in any kind of problem. Because if there's one thing that Jay Lindell's strategic inflection point of space is today, is that the barriers to entry are lower than ever. And they're getting lower. You don't need to be a Lockheed Martin or a Raytheon or a Boeing to reach the stars. You don't have to be a mega company to make a positive difference. So if you think, what if? What problem can we solve? So this is my second of my 3 slides. I've done past, this is present. The present is, what if I could collect hyperspectral data continuously from a nadir-focused point on ELC-4 on the International Space Station and push over 200 gigabytes of data a day down to Earth for analysis. The photo on the top left, that is our first payload, our first sensor package for the multi-user system for Earth sensing, MUSES. MUSES launched on a Dragon, or on a Falcon 9 inside a Dragon module about 1.5 years ago. June of last year it was launched. The Canadarm installed it, robotically put it in while the astronauts were sleeping, and then exactly 1 year later, on another Falcon 9 in a Dragon capsule, we actually launched this first payload, which is for the German Space Agency. And you can see on the top right, that's Canadarm installing the first sensor package, the first canister, in 4 payload bays. It's about waist high. It's about maybe an arm's width, and it has a bore of 18 inches, about 1 forearm length. And that hyperspectral sensor has over 200 spectral bands, 2.5 nanometers per band, collecting data from near ultraviolet to visible near infrared. The bottom left photo is the vegetation index. That is Wheeler Lake, just north of Decatur, Alabama, and just west of Huntsville. The next picture in the middle is suspended matter. The next one is dissolved organic matter. What if I was a commercial farmer and I could get instantaneous real-time data on the drought conditions in my fields, or the pest conditions, or the disease conditions in my crops, down to a 5 to 30 meter ground separation? What if I had that kind of persistent data for U.S. Department of Agriculture, the U.S. Forest Service? The U.S. Forest Service has a $5 billion a year annual budget. They spend half of that on wildfire mitigation. That's not their primary mission. Their primary mission is they are the water engine of the nation. And the Forest Service is committing half of their resources dealing with fires. What if I put a mid-wave infrared and a short-wave infrared sensor in one of those 3 open ports, and with a 90-minute period gave continuous monitoring worldwide of wildfire conditions? Now, we have a space-based infrared system with a operations center about 3 miles that way at Buckley Air Force Base here in Aurora, but security classification guides prevent the space-based infrared system program from sharing their data with unclassified Forest Service operatives on the front lines. What if we could put another sensor on that to solve that problem? What if you fill in the blank? Because we can provide the lift, we can provide the thermal control, we can provide the power, and we can provide the data path. What if you had a sensor idea anywhere on the electromagnetic spectrum that we could deploy and install to solve a challenge or a problem that you may be addressing for a customer? This is the present. This is today. That was installed in June. It was providing those first pictures, and after initial calibration in September, and calibration is continuing, but the data is available. Data are available. The future. Where are we going? Yesterday, you heard about Dream Chaser. It might land in Spaceport, Colorado. It might land in Spaceport, Alabama. You could land it either. We also have at the bottom center, the Space Launch System. Teledyne Brown manufactures that interstage adapter, that trapezoidal cone right between the first stage and the second stage. And the first article that we produced was certified for spaceflight. But the top right, the lunar gateway, there's the power propulsion element. How are you going to move and maneuver when you're going out for months at a time? You could take all of the propellant with you, or you could develop novel approaches like Hall effect thrusters that rely on electricity collected from solar panels to then provide an electrostatic specific impulse. And that very, very top right bubble, in situ resource utilization. Saw a little bit of that with Matt Damon and The Martian, though that's not necessarily involving growing potatoes in your own poop. It's the Martian atmosphere is 95% carbon dioxide. How could you now develop a process where you could turn that into propellant so you don't have to carry it with you? How can we harvest water within the Martian soil and turn that into air? How do we now create other products and commodities that we need for sustained human operations? How do we actually deploy a 3D printer with materials to these places like the moon, like Mars, and actually manufacture and fabricate the environment that we need? These are the kinds of problems that we're solving, because that top line, solving hard problems for harsh environments, that defines Teledyne today, and that defines Teledyne Brown. So if you have a chance to join us this afternoon in our roundtables, we'd love to talk to you. But the thing to take away, what if? Those barriers are low, and everybody has a contribution to make. Thank you. And I'm getting the signal I have a couple of minutes for questions if you'd like to ask. Otherwise, I will pass the ballot. Oh, yes, sir.
Good morning. Being from Huntsville, I just wanted to say thank you for bringing that up. Also, Alabama A&M, the A in the A&M is agricultural, and we have a robust research and development around agricultural science. We're looking at, obviously, agriculture, using geospatial technology for advanced farming techniques, even deploying some of these sensors on UAS platforms as well. So I just wanted to, point out that, you're right on with that. We stand ready to do research not only with y'all, but with others in the agricultural space, utilizing the technology you just mentioned. So that's it.
Thank you. And,
so
and
thank
actually,
you.
and I'd like to point out Alabama A&M University, as well as Auburn and the University of Alabama at Huntsville, are part of the Alabama Remote Sensing Coalition, and have a memorandum of understanding with Teledyne, Teledyne Brown, and we are collecting data, taskable data, for the consortium's use. I understand a stipulation said no data shall go to Alabama and Tuscaloosa, or they had to pay a premium fee. But yeah, thank you very much for bringing that up, and it is, I spent 25 years as a government civilian, a lot of it in acquisition, but it was also on the command and control and communications and intelligence, surveillance, reconnaissance field. Everything has a signature. And if we shift to Jay Lindell's world, the security side, Major General Lindell has been a mentor of ours for years, and if you think, what if I could sense ground separation and potentially a nitrogen signature to indicate an IED has been implanted? If I have continuous surveillance and I know exactly what's happening in the world continuously, and I have the data analytics to detect that change management and to alert a patrol that might be leaving a forward operating base. What if? Space is where we have security. Space is where we get awareness. Space is also becoming contested. And Associate Director Jerzyk yesterday talked about SPD-3, space traffic management. There are nearly 30,000 objects bigger than a softball in the near-Earth environment right now. 30,000, and more to come. About 5,000 of those are satellites, 2,000 of which are still operational. What if I had total situational awareness of not only those, but the other 600,000 that are between a pea and a softball in size? What if I could potentially navigate through that and know continuously what's happening and if something changes? Those are the kinds of challenges that we need to be thinking about. And it's through organizations like NASA that enable that with their SBIR and STTR programs. So, another question? Yes.
Besides coming to conferences like this, what other mechanisms do you use to data mine for technologies that you can use for these platforms?
Oh, excellent question. So you might have noticed on that opening slide it said business development. I'm not an engineer, but I might play one on TV. I actually have a degree in physics, but my work is about trying to find those opportunities, and there are two ways. We can look both at the government, what's going on in broad agency announcements and RFPs, the filters through FedBizOpps and GovWin. There are also new contract mechanisms and new agreement mechanisms with other transaction agreements. Undersecretary of Defense Mike Griffin is a big proponent of OTAs. And if you're a small business, you qualify as a non-traditional defense contractor, look up Space Enterprise Consortium, look up C5, look up ATI.org, and pay the $500 membership fee to get access to these OTA opportunities, because we're 900 people in Teledyne Brown, about 10 of them here in Colorado, including me and my esteemed colleague, Stacy DeFore, who everybody in commercial space knows. But most of that bulk of manufacturing and personnel is in Huntsville. Even though 900 might qualify as small in some NAICS codes, because we're part of the 10,000 person Teledyne Technologies through small business affiliation rules, we're not small. We can't prime an OTA unless we bring a 1/3 cost share. Small businesses, though, you've got a free pass. You guys can get right there with a quick turn, usually 90 to 100 days for award. And the Space Enterprise Consortium vehicle was just increased in ceiling from $100 million to $500 million. And Space and Missile Systems Center at LA Air Force Base is looking to grow that. So that's the government side. The industry side, part of it is through venues like this, part of it is just through market research, which we are doing continuously, but our sensors are imperfect. So if you have an opportunity or a contribution or want to be part of a team or bring Teledyne onto your team, with our manufacturing, with our modeling simulation, with our coding expertise, we'd love to talk to you. Okay, that's all my time. I'd like to yield the balance of the floor to Mr. Reed from United Launch Alliance, which has a 131 consecutive launch string, a 100% success rate, and nobody else can make that claim. Good.
And now to figure out how to bring up the chart deck quick. And I took a slightly different tact. I went with lots of cool pictures and not much to say, so. And full screen. Do. Is it behind there? Under file? Yeah, okay. That's okay. Right there. All right, so we'll fly through this. And I'll probably just hold questions at the end when we're doing the networking break so that we can go have more coffee. A little bit about ULA. We launch rockets. We deliver vehicles to space, and fairly shortly we'll deliver people to space again. But we basically have three customer communities that we focus on. National security space, where we really focus on helping our customers save lives. NASA, where we help our customer explore the universe. And then also the commercial community, where mostly what we focus on is connecting the world with data services, communication services through the different commercial satellites that we launch. As I said, the other big thing that's coming up is we're returning humans to space coming up this next year, finally launching again from US soil. Small fact that probably all of you know, we used to launch people on Atlas rockets, and we're about to launch them on the newest Atlas rocket, the Atlas V. As was alluded to, we've been launching rockets successfully for many years. I think I'm the youngest company that came up here to talk. We're a joint venture that was formed in 2006. So while we've had success, this is just since we formed back in 2006. Our headquarters are here in Denver, where we design the rockets. We have about 1,000 rocket scientists that love living here in Colorado. Another small fact, I've been doing rockets since 1986 here in Denver. I've managed to stay here as we formed or brought the Centaur vehicle and Atlas out from San Diego, as we merged with Lockheed and became Lockheed Martin, and then formed the joint venture with Boeing. We keep pulling all the engineers here to Denver, so I was a pioneer in that effort, as it were. We do have a couple different coasts that we launch on. We launch from Cape Canaveral and Vandenberg Air Force Base. We do currently have 4 pads out there, 2 at each coast. We also have our production facility down in Decatur, Alabama. We have over 2 million square feet of manufacturing. If you ever get a chance to go out there, I highly recommend it. It's an incredible production facility for building some of the biggest vehicles in the world. I was reminded, I was just down there a couple weeks ago, and somebody pointed out that there is an automotive factory not that far away that dwarfs our factory. So there are bigger production facilities. But to see the rockets being assembled and built and welded and everything coming together in one floor plan is just kind of amazing. A little bit about our business. Part of what we do is service the entire market. You hear a lot about low-cost LEO access, and that is an important capability that we need as a nation to be able to bring satellites to orbit, to bring people to orbit. But there's a lot more to space, and a lot of those orbits are harder to get to than LEO is. LEO is far and away the simplest orbit to get to. You're basically talking a short burn to get there. But we serve, for the Air Force and for NASA, within Earth orbit, the entire constellation of different orbits that people need to get to, anywhere from a LEO, a polar orbit going north-south over the poles where you can get a sun-synchronous path so that you get constant lighting when you're doing those observations of the Earth below you, to the MEO orbits where you've got your GPS satellites. What those do is give you constant coverage by having a couple different planes so that you can have data linkage through your phones from anywhere in the world through that constellation. Out to GTO for the commercial birds, or a direct inject geostationary orbit for some of the other applications. And so what you can see is with the vehicles that we have varying levels of performance just because it takes that much more energy to those higher energy orbits further out you go. Part of the challenge in that is you're talking operating a lot longer if you're going to a geostationary orbit. You're also needing a lot more energy to get there. So with the LEO, what you're able to do is just have a 10, 15-minute orbit or mission from liftoff to insertion. And even for the smaller guys that are up and coming, like Rocket Labs, they're able to basically do a direct inject to a LEO orbit with just burning continuously to get there. One of the things that we do for some of the polar orbits and other applications is do a tube burn where we're able to get to a higher LEO altitude. What that gets you is a better position for those Earth observation missions. And then we also do all the different burn types to get out to the geotransfer orbits or geostationary. The other thing that is important to recommend or remember is the accuracy that you need to have for going out to those larger orbits. You have to get better and better performance. Part of what we get out of the GPS system here on Earth is you can have very precise knowledge of where you are. Once you get above that the GPS constellation, you really can't get the benefit of that system anymore. And so basically any error that you have in that system is going to continue to grow over time. And so part of what we bring to the market are solutions that really maintain a high level of injection precision so that you're not wasting spacecraft fuel to get into the orbit that you wanted to get to. Fairly quickly here, this is one of those fun graphics that kind of gives a lot of different ways of thinking about the launch vehicles and our Centaur upper stage. One of the things I like to point out is that that upper stage is the highest performance stage, in part because it's so light. So what we've effectively done is created a steel balloon that holds all the fuel, so the mass that's left is just in the engine and in the avionics structure. What that allows us to do is then deliver all that performance that's there in that stored fuel to getting that spacecraft where it needs to go. As many of you may have heard, we are in the throes of developing the Vulcan Centaur vehicle. This is kind of what's going on right now. Up to this point, we've been operating the Atlas and Centaur that we developed previously, trying to deliver the best performance on those. One thing I will point out is part of the structure that we were created under as a joint venture was to try and reduce the cost of launch. What we were tasked with for those first 5 years was to find ways to reduce the cost of launch by 5% a year each of those years. We've managed to continue that such that at this point it's less than half of what it used to cost when we first formed to launch to space on one of our vehicles, on the Atlas vehicles, than what it cost now. So you kind of reach an asymptote where you really can't drive more cost out of a fully designed system. What we're looking to do with Vulcan is then take it a step down further so we can get to that better price for access. I think we've already talked the launch site. So you can see what we've done with Vulcan Centaur is tried to take the best elements and aspects out of the systems that we're operating now to form the new system that we're going to be operating in the future, the Vulcan Centaur. With that, I'll also say, I'll touch on it in a second here. With that, we are getting a lot more performance out of these vehicles, so you can see the increased performance above our Centaur 551 variant, which is what we use for, it's kind of the workhorse for the heavier satellites. To do Vulcan Centaur, part of what we've done is brought the manufacturing team into Denver in the design process early on so that we could basically design that system for manufacturability. And we're now starting to see that as we're putting all of the weld stations and all of the new capital investments out in the factory to start producing those Vulcan elements. So we've got a universal weld system, we've got a circumferential friction stir weld system. I was out there a couple weeks ago and got to see the pad that they had poured for one of the new welders. It is a 7-foot thick concrete block that they poured. 55 cement trucks rolling through the factory to pour that. The other thing that we've done is really focused on strategic partners. So we now have Northrop Grumman as a strategic partner for the solid rocket motors we use. RUAG we have as a strategic partner to do the payload fairing and composite materials. Blue is our partner for the booster engines and AR for the upper stage engines. And L3 is our partner for the avionics. What we're trying to do there is leverage their expertise. Historically, companies that have done things for a long time tend to go, I know how to do this, let's go do it my way. What we've tried to do is really engage those partners to say, we're looking to make really innovative changes in how we do things so that we can get that best value for the customer community. And so we're leveraging their best know-how as well as the wealth of experience that we have on what these environments are like that you have to operate and survive through. Another thing is the launch pad modifications are already underway. We are in the throes of getting ready to launch people, but we're also trying to cut in those new hardware elements as we can so that we can retrofit those launch facilities to be ready to take the new Vulcan system coming up. Cool picture of the rocket without the payload on top. One of the things we do is we encapsulate the payload and then bring it to the launch site when the rocket is already erected, just to reduce the exposure to that payload to environments out at the launch site. But it's kind of strange to see a rocket with a flat top. So wanted to pivot a little bit. We talked a little bit about how we're trying to be more innovative with our partners. What we're also trying to do is look for opportunities where there's mutual interest in developing technologies. So one of the things I'm tasked with is ULA's reuse path forward. So what we're looking to be able to do is recover our Vulcan engines and reuse them to provide a lower cost reflight opportunity for the community. To do that, we looked at the way other people have done it and did a bunch of trade studies. What we found is there's a significant performance penalty if you try and fly that rocket back to the ground. So what we've tried to do is develop a technique where we can have a minimal impact to the community or to the primary customer and still get those engines back. It turns out NASA was also interested in the HIAD technology for re-entering or for entry at the Martian atmosphere in that environment. And so what we've done is partnered to try and develop a roadmap to expanding the capability of those hypersonic inflatables and the flexible thermal protection system. And so NASA had done the ERB-3 program on their own internal work, and we've teamed together in developing the lofted flight test article. So NASA is developing that test article, and I'm figuring out how we integrate it into a rocket ride and how we dispose of the Centaur in a way so that we put that reentry vehicle onto the right reentry path and we can recover it. So we'll actually be able to recover that heat shield and see what damage occurred, understand what those environments are like. Then based on that, we can take the lessons learned on our side and scale it for engine reuse, and they can take those lessons and scale it for Mars reentry. So I think I'll probably wrap it up here. But basically, we are kind of the transportation company. I like to call us the FedEx of space. Our job is to get whoever needs to get to space wherever they need to go. We have now launched payloads to every planet in the solar system and now the sun with Parker Solar Probe. And what we're always looking for is partnerships to figure out what the needs are of the community in the future, make sure we have a path to get to the technology and capability to serve those needs. We're always exploring the future of space transportation too. I think part of what we always want to do is look for what is the future state that we could have where we're a piece of it, but there's a vibrant community out there. I think many of you may have heard Tori speak previously about Cislunar 1000. And really that's a vision for what the future could be like, where you have 1,000 people living and working in space. Our whole focus in that is how do we serve the transportation needs in that kind of environment? The other thing is we're always looking for those innovative ways to enhance our vehicles and processes. So those are all the different kinds of things that we're interested in. I'm always talking to people about and trying to understand what other people's technologies and adjacent markets are focused on. You know, so our whole goal and vision is really to have a community working to harness that potential for humanity in space. So with that, I think I will let you all go have a networking break.